how to find surface areas. Okay, surface areas are used to solve for the area of a 3D object. Okay, so that's the area. How do you describe the surface area if you want to describe it to me? Like the surface area. I'm looking at the surface area. How would you describe that? It's not the volume. There are two different things.
So is it the same?
Sum of all sides.
The sum of
All the sides.
that would be perimeter. Okay. What's the surface area?
This whole area outside, inside?
It's just the
Sides.
outside.
Just outside.
Just the outside area. Okay? So if I want the surface area of this room, right? If I want the surface area of this room, I have to find the area of the back wall, the area of the side wall, the area of the wall behind me, this area, the top area, bottom area, and then sum them all up. Okay? So when you're looking at surface area, right, usually you're looking at how much material do you need to build something. Okay? So let's say if you also looking at wrapping a box, right? Wrapping a present, right? You need a surface area, which means how much area do you need to cover that box, okay, with a wrapping paper. So if I have a regular shape, right? So if I have a box, or if I have a rectangular prism, or a triangular prism, whatever it is, right? So let's say I have this right here, right, which looks like a cube here, right? If you want to find the surface area, it's as easy as finding the area of all the sides, right, and adding them all up, right? Or it's as simple as using your formula sheet that gives you the area of a rectangular prism, right? It gives you a formula. Right? You have the formula sheet in front of you, or you can grab that. Okay? So this is one way that you can do it. You can look at the formula and then find using the formula. Okay? But what if I tell you, well, in this case, I want you to wrap this present, but without the top. I want you to keep the top unwrapped. Can you still use that formula in your book? So you have to you have to change it. So it's not the same formula that you have there. Okay? Now what if I say, now I want you to find the surface area of this shape right here. Can you find a formula for me in your book?
Is this one right? Triangle?
Can you find the formula in your book?
Is it the last one?
No.
Triangle?
Right?
No.
So what do you have to do if I ask you for the surface area of this?
Fold it down. Lay it out into 2D.
Can you say that?
Lay it out into 2D shape.
Lay it out into 2D shapes. That means open it up, right? And then see what 2D shape you got. And now you got a composite figure, no? Right? If I open this up, I'm not going to open it up just because I don't want to put it back together. But if you open this up, right, you're going to get a 2D shape. You're going to get a flat shape. You're going to get a composite flat shape. You're going to do the same thing as we did yesterday, right? Where you're going to have this side, whatever, how many sides you have, you can find the area of each, add them all up, or subtract if you need to. Okay? Now, what do we call this? So we call this the net. Okay, when I open this up, I call it a net. Okay? So even if I have the box here, I can open that box, right? And then make it into a 2D shape. And you see right now I have a 2D shape that I can fold together at the end and then make the 3D shape. Okay? So this is called the net. Now if I open this one up, what do you see? What do I have?
Squares.
6 squares. Okay? So if I fold the 6 squares, they give me the cube in this case, right? Now you need to understand that each shape have their own net. Okay? So this is a triangular prism. Okay? What would would be, if I open this up, what would I have?
Squares, rectangles, and triangles.
How many rectangles? 3 rectangles, and how many triangles? 2, right? So if I take this apart, right, you're gonna have 3 rectangles, right, and 2 triangles, right? What if I have a pyramid?
Square.
Four and then square.
It could be a square if it's a square-based pyramid, which that's what we deal with usually, for a square-based pyramid, and then you have the 4 equal triangles. Okay? This is how they came up with the formulas of the shapes, of the regular shapes, though. Okay? So they do put it down into their 2D shape, and then they find the area of each, and then they add them all together, and they came up with that formulas that you see on your formula sheet. Okay, so your job for today is to actually draw the nets, okay, and then to find the surface area using the nets. Why are the nets important? The nets are important because, as I said, when it comes to questions where I don't want to know what the surface area of the full box. I just want to know what the surface area of the box without the top, right? Or I want to know what the surface area of this pyramid without one of its sides. I want to keep this one open. I want to keep it as a door. And I just want to know what the surface area of the 3 triangles and the square at the bottom. Okay? So that's when you have to think and use your own knowledge to alter that formula that's given to you. Does that make sense to you? All right. So a net is a 2D pattern. That's a D. That can be folded to form a 3D shape. Excellent. So if you work in a restaurant, or if you work in a retail place or whatever, you know, like, I mean, we don't get these as you see them. We get them as a flat cardboard, and then we put them together to form this. Okay? I'll show you. I can show you. I don't know if we have any open ones, but this comes as a card, right? And it comes as 2D, and then we put it together. They tell us like fold 1, fold 2, fold 3 to form this. Okay? So like same as a pizza box, right? It comes as a flat 2D shape, and then you put it together to form that pizza box. And the surface area of a prism is the area that it would take up if it were laid out flat as a net. Okay? So if I actually open this up, right, as I said, and then find the area of all the sides, add them all up, that will be my surface area. Here's a shape, prism, and you're asked to draw the net of the following prism. So what would you draw here? What do you have?
2 rectangles.
2 rectangles?
No, 4, sorry, 4 rectangles. The other side.
Plus squares.
Okay, how about you think about it first? Let's think about it first. Let's think about it first. Okay? You're going to look at this shape as one whole shape. Okay? This is one shape. You don't want to separate this. Okay? So think about it before you answer, and if you want to answer, put your hand. If you're ready to answer and you know what it is, you can put your hand up. Okay, so what do you think? Yeah, go ahead.
5 rectangle,
5 rectangles,
and these 2 house shapes,
2
2
pentagons. Yeah, a 5-sided shape is called a pentagon. Okay, so we have you see here, you see the 1 and the 2, right? There is a 1 and a 2 on the other side, and then you have the bottom, right? So you have altogether 5 rectangles. Now, if you see here, guys, eyes on me for a second because this is important. Not all the time you get all the sides to be equal, right? In this case, if you look at this pentagon, it's actually a regular pentagon. So all the sides are equal to 10, right? Sometimes the height is not the same, or sometimes the base is not the same, right? So we're lucky here that this is 10, this is 10, this is 10, which means this is 10, this is 10, right? Which means also these are 10s, and that makes all my rectangles to be exactly the same rectangles. Okay? So when I'm drawing my rectangles, let's see if I can do that. So you're going to have 5 of them, and they're going to have to be exactly the same 5 rectangles. Okay? And then you can draw the pentagon whatever you want on whatever side you want. Okay? You can draw it on the second, on the third. I usually like to draw it on the middle. I tried to make them all look the same, but no. Okay? So what also you need to do when you're drawing a net, you need to let the person that you're drawing the net to know what your side lengths are. Okay? All what you need, because all of the pentagon side lengths are the same, right? You just have to put, so indicating that all of these are the same, right? This is 10, this is 10, this is 10, this is 10, 10, 10, 10, 10, right? All of these are the same. It's enough that you just show this and write 10 somewhere, okay? To show them that it's 10 centimeter. And then how about these side lengths? What would that be?
30.
30, and they're all the same, right? So they're all 30. To indicate that they're all 30, we're going to indicate them all together as the same. So we put like double dashes or whatever you want to do. Okay, to indicate that they're all 30. Okay, so if you want to find the area of this, what do you do? One at a time, please. I can't hear you. Number one, when you're talking together. Number two, you're talking to.
I have almost 5 rectangles with 10 and 30.
So I have 5 rectangle with 10 and 30.
And
Yep.
I have 2 square.
Okay.
10.
So you're looking at this, correct?
Yes.
Okay.
And I have 2 triangle.
Yep.
I guess so. The regular triangle.
It's an equilateral. Mhm.
So I will find the height of this equilateral.
Yeah. Yeah. That's right. Okay.
And
Yeah. Keep going.
the height I can find it because it's up from vertex
Mhm.
to base.
Mhm.
So it's in the middle.
Mhm.
So I can find it. I can use Pythagoras
Yeah.
theories to
Yeah.
find the height.
Yeah. Perfect.
I don't know if there is a
There's an
easy way.
easier way. No. Right. So Wafa was saying, okay. So we all agree that there is 5 equal rectangles, right? So find one and then multiply it by 5. Boom. We're done. Okay. Now, in the pentagon, we don't know how to find the area of a pentagon unless we split it, right? So we have to split it into the 2 shapes, right? So we have the square, which is 10 by 10 here, right? And I have 2 of them. But then the problem is with the triangle. Because if you look at this triangle, right? I don't know what the height, and for a triangle, I do need a height. Because what's the formula for an area of a triangle? Base times height divided by 2, and I don't have that height. So I need to find the height. Right? So I don't know what this is, but I know this is 10, I know this is 10, and I know this is 10. So what do we do to find that height? Divide the base by 2, and that only happens when you have an equilateral triangle. You know what an equilateral triangle is, correct? Yes? All sides are equal? Equilateral? Okay? When I have an equilateral or isosceles, these are the two cases when it actually cuts this in half. So that becomes a 5. Okay? Then? Pythagorean theorem, right? Which is 10 squared minus 5 squared. It gives you the height squared. Okay? Once you do that, you can find the area of that triangle. Now, this question does not ask you to find the area, but it's a good extension that we can think about. Okay? So, what I'm going to do is I'm going to let you try to find this area. Okay? See if you can do it. Check your answer with the person sitting next to you. And then you are going to draw a net for this and find the area of it. Okay? You can work with a group of 2, group of 3 if you want to do that.